Next is your asymptotic unbiasedness. Now, what are the criteria of asymptotic unbiasedness? That asymptotic mean, beta height, should be equal to the population mean. It is expressed as limit expected beta height for n samples is equal to population mean. So when n is very, very large. Now, the difference between this asymptotic mean and the population mean is the asymptotic bias. So if suppose beta is transferred to left side and the difference is some constant, and in that case there is biasness. So that difference is the asymptotic bias. So it is limit expected beta, estimated beta n minus beta. So n, when n is very, very large. If n is very large, then difference will vanish. So when n is small, then there is more chance of biasness. When n is very large, so it is said that the difference will vanish. That means there will be no difference. Okay. Next is consistency, asymptotic consistency. So we have discussed unbiasedness and this is consistency. So to become consistent, there are two conditions. First is there should not be bias. Just now we have discussed that limit expected beta height for n samples is equal to beta when n is very large. First condition. And second condition is that variance of estimated beta should be 0. It is approaching towards 0. So for say n1, n2, n3, so on, gradually it will go on declining and declining. So it will approach 0 for n number of samples. Then when variance is 0, suppose it has approached 0, variance is 0, distribution collapses on the value of the true parameter beta. It is known as degenerate distribution. So when it is collapsed, there will be no difference. If the variance is 0, then it is known as degenerate distribution. And consistency holds true for higher sample. It will provide perfect estimate of true beta. So when the sample size will be higher or higher sample, it will provide perfect estimate of true beta. So this is always said that instead of taking very small sample, we should always take larger and larger sample so that the estimated beta is consistent. And nearness, even if it is not equal, it should be nearness and nearness to the population estimates. So to be consistent, the biasness and variance should decrease as n becomes larger. So this is a general concept that when n is very, very large, larger and larger, then the estimates will have less biasness and less variance. So it will decrease when number of samples will increase. So at very large sample, when it is and tends to infinity, they become 0. Biasness and variance become 0, and consistent estimator will be a perfect estimator. It will be perfect when n is infinity. Then asymptotic efficiency of estimated beta. So it will be efficient, two conditions. It will be efficient if estimated beta is consistent, so we have already discussed earlier, and estimated beta has a smallest asymptotic variance compared to any other consistent estimator. So this is the condition for asymptotic efficiency, that estimated beta must be consistent, and second, estimated beta has a smallest asymptotic variance compared to other consistent estimator. Now, beta head, so this estimated beta, is asymptotically efficient if 1 by n, that means reciprocal of the sample size multiplied by expected values when n tends to infinity, that square root of n, square root of the sample size multiplied by this variance, beta head for estimated beta for n number of samples minus beta square multiplied by this. And what result will come will take estimated the expectation of that. So this value should be less than 1 by n, limit n tends to infinity, so when n is very large, and the expected value of b star, that is beta star for n number of samples minus beta square. What value will come? The square, the expectation of that. Now, what is beta star? Beta star is any other consistent estimator of beta. So this is the population parameter estimate. So any other consistent estimator. So asymptotically efficient estimators variance approaches faster to 0 when n is sufficiently large, when n is very, very large. So the variance of the efficient estimator will quickly approach towards 0, or approach will be much faster towards 0. So this is all about the efficiency and consistency and all other properties of large sample. So we'll go through the PDF in details. Thank you very much for watching. Go on watching, and please share. Thank you.